Alright, so we are going to get started today with some data manipulation. We're going to use one of R's built-in data sets, but the principles are exactly the same if you're working with your own data set. So we're going to work with the Gapminder data set today, and you're probably going to need to install it. So go ahead and type install.packages and then Gapminder. And this data set is population, life expectancy, and GDP of many, many different countries between 1957 and 2007. And for more information about the Gapminder dataset, you can always type $Gapminder. Go ahead and run that. Oh, 2 question marks, Gapminder. Now go ahead and run that. And you get a little bit more information here. There is an unfiltered data set. This data is not totally complete. And the way that the built-in data set is structured, there's no way to quickly clean it to figure out which rows are complete, which rows are not, or which cases are complete, or which observations are complete. Okay. So for whenever you want to whenever you want to select and slice and wrangle your data, you're going to want to work with the tidyverse and dplyr packages. So we'll go ahead and load our library, our tidyverse. We'll load our library dplyr. And we will load the Gapminder dataset because it's, sort of built in. It actually comes in package form. Okay. Go ahead and run all 3 of those, and that will just load the packages into your environment. I don't think that they ran. There we go. All right. So our goal in this project is going to be to get a deep understanding of what data is available in the Gapminder dataset, to be able to slice it up into different ways. We're going to save a file out that we have sliced from this dataset. We're going to focus on the numeric values, and we'll do a minimal visualization just to kind of illustrate the relationship between the variables. Okay. So in dplyr, there's 5 functions that operate on 3 categories. There's select and filter, which both operate on variables. So both select and filter operate on columns. So I'm going to make a note here. Columns, I can select or filter. If I want to change something about my rows, so I either want to select certain rows or I want to change a row and make a new one, the things that operate on my variables or my rows are arrange or mutate. And once I have elements grouped together, so we're going to do a little bit of group by today, then I have summarize. And this will do different tabulations of those groups. Okay, so the first thing that we want to do is load in our data. So we're going to say data, and we want the Gapminder dataset. I'm going to go ahead and run that, and that just loads my Gapminder dataset into my environment. Okay. And good practice, even though we know a lot about this data, we want to check what it looks like. So I'm going to glimpse the Gapminder. Run that. It looks like down here I have a bunch of countries. I have a bunch of continents, years, life expectancy, their populations, and the GDP per capita. One thing I want to note about the populations, so they're integers, and that's fantastic. However, they are very large integers. So depending on how your R installation is set up, actually I know that everyone here, your R installation is set up that we're going to need to do this. We are probably going to get an error or a warning at some point when we're manipulating the population that our output is going to be too large. So I'm just kind of making a note that these are pretty large numbers. They're integers, but they're pretty large. So I might want to deal with that later. Looks like these were read in as factors, both of my, my categorical variables. Keep that in mind in case I wanted to do some sort of string manipulation. I would need to change those to characters. Okay, and everything else looks pretty good. I got some decibels in my life expectancy and my GDP per capita. It's not surprising. And years were read in as integers. Looks good. All right. So I'm going to see, I'm going to look at the head of this and the tail. So I'll run both of those, just make sure nothing looks crazy and it all looks like I expect. Yep, it looks like I have Afghanistan. Those all look like reasonable numbers. And down here in Zimbabwe, yeah, those all look pretty good too. Excellent. So there's one more thing that I want to find out. Now, I've never worked with this data set. There are over 1,700 observations, so over 1,700 rows. So I'm not going to be able to look at all 1,700 rows. But I want to know if there's any NA values anywhere, because that's really going to affect how I analyze this data set. So a really quick and kind of shortcut way to get there is to type sum. So I'm going to add is.na, and I'm going to pass it the gapminder entire data set. Now, let's run that and break it down a little bit. So sum means to just add up. Now, is.na finds any NA value and assigns it a value of true or false. And as you may already know, the value of true is often associated with a 1, and the value of false is often associated with a 0. So what you're doing is you're adding up all of the 1s. So you add these together and take the result and find out that there are no missing values in your data set. Fantastic. I'm going to pause right now and point out that I made a mistake much earlier. I called this variables. It is actually observations. So arrange and mutate works on observations and rows. Sorry about that misspeak. Hope that you are okay with this. I will leave this big, bold observation here for the rest of the course. Okay. All right, so we are going to get started on some operations about our variables. So we're going to select some variables. We are going to filter for some variables. They kind of do similar things, select and filter, as you will see shortly. So the first thing that I want to do is I want to make a new data set with just 2 variables in it. I want there to be just 2 columns in my data set. Maybe I don't want all of this other information. I don't want to keep carting it around. So I'm going to call my new data set GP CNT life, because what it's going to be is just country and life expectancy. And I'm going to assign this to select, and the select function wants a data set, so I'm going to pass it the gapminder data set. I'm going to tell it which 2 columns to select. So I'm going to say country and life expectancy. Okay. Go ahead and run that. And I have no idea if that worked or not. So let me look at the head of that and just make sure that it worked. And it looks like it did. I went from the 5-column, 6-column data set down to this 2-column data set. Excellent. All right, now let's say I want to select everything except for the population. I just want to drop that column. I don't want to carry it around. I don't want to even be tempted to manipulate it. I'm going to call this GP no pop. And again, I'm going to assign it to a function, and that is going to be select. I'm going to pass select the gapminder data set. And rather than passing the columns that I want, I'm going to say negative the column that I don't want. So just negative pop. I'll go ahead and run that and check the head to make sure that it worked. And I'll run it. And excellent. I have this 5-column data set here with no population. Awesome. So select will only keep or drop columns. That's the entire point of the select function. Filter, on the other hand, will allow you to filter columns based on, or filter rows based on a column value. So let's say that you only want to work with the year 1957. You would filter the year column based on the values in that column. So you would say, give me only the years that are equal to 1957. You could also say, give me only the countries that begin with the letter A, or something like this, or the countries that end with the letter A. So the filter function allows us to grab columns or grab rows based on column values. So the filter function works a little bit differently, and we are going to work with the pipe operator, or the pipe operator for the first time. Now, we're not going to get too deep into this, but if you're really interested in where this comes from, go check out René Magritte's Treachery of the Images. We are really far off course, so just know that the pipe function is linked back to this moment in art. Okay, so we're going to filter our data set on only the row, on only 1957. So I'm going to call this GP underscore 1957. I'm going to assign it to, I'm going to select the gapminder data set, and then I'm going to use this pipe, and I'm going to say filter year equal to 1957. And we remember that our 1957, that our year variable was read in as an integer. So we don't need quotes or anything. 1957 will just be read as a number. So what we've done here is we've passed the gapminder dataset to the filter on year 1957 function. And we've said, apply this function to everything in the gapminder dataset. Okay? And then make a new dataset out of it. So go ahead and run that. And we get a warning message, and we don't worry too much about it. I have the versioning message, you might not have it. So go ahead and type head GP 1957. And we'll run that. And we only have the year 1957. That was fun. So now let's try to filter on a country. So I'm going to filter for the US. You can filter for whatever country you want. And I'm going to say GP US and assign it to gapminder, pipe, and then filter country is equal to, and this has to go into quotes and it has to match exactly. So United States in your data set has to be spelled like this. It can't be the United States or the United States of America or any other variation. This is actually problematic for a lot of things because there are a lot of different spelling variations. So you have to know what your data set looks like. The way you can figure that out is either by calling unique on a column, which we did earlier, which may give you an unwieldy list, but you will be able to find some variation of what you're looking for. Okay, so we are going to filter only for the US. Go ahead and run that. And then I want to look at the head. So I'm going to say head GP US. But this time, let's say that I want to look at not just 6 rows, but I want to look at 10 rows. Okay, so I say n equals 10. You can look at as many rows as you want. You can also save this as a different function if you want, if you only want the head of a data set or a sample or something like that. Okay, we'll go ahead and run that. And we get the first 10 rows, and it looks like we have all the United States for every 5 years from 1952. Excellent. So you might be asking, well, this is all great, but I have 2 variables that I want to filter by. That is no problem. R can handle it. Let's look for Asia in 1957. So we're going to filter by both the year and the continent. Okay, so we'll say GP 1957 Asia, and then assign that to Gapminder. We'll use our pipe. So we're passing the Gapminder dataset to our function. We are going to filter on country. Nope, we are going to filter on continent equals Asia, and year equals 1957. And remember, the reason we need quotes around Asia is that it was read in as a factor. So if it's a factor or a character, you need quotes. But the year was read in as an integer, so we do not need quotes. So we will go ahead and run that, and then we will check out what is going on with it. So I'll look at the head of GP at 1957 Asia. And this time, maybe I want to look at n equals 8 records as opposed to 6. All right, so it looks like my data set has been successfully filtered on both the continent, Asia, and the year, 1957. You can do the same type of manipulation if you want to say, look at all years under 1960. So the way you do that is just GP less 1960. And we'll pass the Gapminder, the pipe in order to pass it from one side to the other. And then we'll filter year is less than 1960. Run that. And then we'll get the head of GP less 60. And we'll look at the first 15 rows. Run that. And it looks like we have all of the years that are less than 1960. So you can pass greater than any sort of function like that. All right, so that is all that we really do with filter. Now we'll move on to arrange. So arrange also operates on variables. And what arrange does is orders them. So it'll order them from smallest to largest, or you can specify that to order them from largest to smallest. So let's arrange our Gapminder data set by the population. So we want to see what country on what year has the smallest population. So we go Gapminder, and then we pass it the pipe, and arrange by population. You'll notice now that for simplicity's sake, I'm not going to keep saving these out to new variables. Rather, I'm just going to do these operations in place on Gapminder. That means that they only exist temporarily and they won't persist. So when we call Gapminder the next time, it will not be arranged by population. Okay, so I've arranged it by population here, and we see that Sao Tome and Principe in 1952 was the smallest population with only about 60,000 people. And then the Sao Tome and Principe and Djibouti traded off back and forth. All right, so we can also arrange descending. So we can say Gapminder, and then pipe it and arrange, and we'll say descending pop. So we just pass the descending function and then run it, and this will put the largest country on top, which is, not surprisingly, China in 2007. Great. We can also combine these functions. So let's say I both want to filter and arrange my data set. So if I want to filter and arrange, I'll go Gapminder, pipe it, and then first I'll filter by year. Let's say we want to find only 1957, and then arrange, and then another pipe, and then arrange, and I'm going to say that I want to arrange descending to find the GDP per capita. You could use this, or you could use population. It doesn't matter. I'm going to change it up, use GDP per capita. So here we have first divided our data set to have only 1957, and then we've divided our data set to organize it in descending value to make the largest GDP per capita on top. And in 1957, we find that that was Kuwait. Excellent. So that's it for arrange. Now we're going to move on to mutate. So mutate is the way that you change a variable. So we're going to experiment with this by working with our population variable and our GDP per cap, because again, these are our numeric variables. So the first thing I want to do is divide my population by 1,000,000. Since there are, this is raw population numbers, and we often report population by the millions rather than a raw number. So I'm going to say, read in the Gapminder, pipe it by, and then mutate, and then I'm going to make a new pop that's labeled the same as my old pop, because this is a really easy transformation to recover. And I'm going to divide it by 1,000,000. 1 and 6 zeros. All right, so I go ahead and run this, and what I find is that my pop goes down to this decimal, right? But notably, if I call my Gapminder again, that variable is not stored. In order to store it, you can either reassign it to Gapminder, or you can assign it to a new variable name. But here we're just experimenting with the different verbs, so we want to keep our original Gapminder in place and just illustrate how to perform operations on this column. All right, so now let's try to mutate our GDP. So in addition to doing division, you can also do multiplication. So we're going to go Gapminder, pipe it over to mutate, and then we're going to say our new GDP is equal to GDP per cap times population. Because here, we have our GDP per capita, and then multiplying it by the population gives us the overall gross GDP of each country. All right, and we see here that it has multiplied out into this very large number. If we wanted to then find out which one was on top, we would need to, again, arrange it in descending order, just as we did up here with multiple verbs in line. All right? Okay. So the next thing we are going to do is make a big sentence with mutate, filter, and arrange. Our goal is going to be to find the top 5 highest GDP countries in 1957. If you want to try it yourself, pause the video, try to write it out, and see if you can build this sentence yourself. So we're going to start with the Gapminder dataset, because we know that's where our data is, and we're going to pipe it over to, now we need to find GDP, not GDP per capita. So I'm going to start by mutating it so that I have all of the columns that I need in place before I start doing anything else. So I want to get my data set in place before I start ordering it and things like that. So I calculate a new GDP that is equal to the GDP per capita times the population, same as we did before. And then I'm going to pipe this, and I'm going to hit enter so that it goes to 2 lines. Once I pipe that and I have the GDP calculated, then I want to filter. And I'm going to filter by the year 1957. And then now I have the GDP column that I want, the year that I want, and now I'm going to arrange it so that the top 5 are on top, descending GDP, right? So we will go ahead and run this whole sentence, and we find that in 1957, the top 5 GDP countries were the US, Germany, the UK, Japan, and France. You may take issue with the UK being designated a country in this data set, but that is a different discussion. All right, so we didn't assign that to a variable. If we wanted to keep this data frame, we would assign it to a variable and then save it out to a new file. And we will do that later on in the tutorial. All right, so we have made it through both column and row operations, both variable and observation operations. Now we're going to start looking at group by. So group by is a way to tabulate different aspects of your data set. So you can group by any column name, so you can group by any variable in order to get the mean, the median, the mode, and things like this out of your variables. Okay, so we are going to summarize our Gapminder data set by the mean life expectancy. So type Gapminder, and we're going to pipe it over, and we're going to say summarize, and then we're going to calculate a new column, and it's going to be mean life expectancy, and it's going to be equal to the mean of life expectancy. And this is going to return to us just one number. So we'll go ahead and run that, and I made a typo. It's the mean of life expectancy, no capital L. Important to name your variables right. All right. So the mean life expectancy is 59.5. What does that number mean? Well, our sentence here said summarize the entire Gapminder dataset. So find the average life expectancy for all countries across all years. So the mean life expectancy for everyone on the planet from 1957 to 2007 was 59.5. Now, that doesn't actually tell us very much. It would make way more sense to find the mean life expectancy globally for 1 year at a time, since we know that things like life expectancy change year by year. So, to figure that out, we first need to filter by the year. So let's say that we want to filter by 1957. So we will say gapminder, and then we will pipe it over to filter by the year 1957. And then we'll pipe that over to summarize by mean life expectancy, life EXP, and set that equal to the mean of life expectancy. All right. So we have our data set. We're filtering for only 1957, and we're going to make a summary for 1957 that is the mean of life expectancy. I'm going to run that. The mean life expectancy in 1957 was 51.5. Okay, still, that doesn't exactly tell us everything that we want to know. So it would be way more meaningful if we could get the life expectancy for every year. And then we could actually start to graph what's going on with life expectancy across the world at every year. So let's go ahead and do that. So we're going to start with our gapminder dataset. We're going to pipe it over to our new function, which is group by. So group by tells us to put all of the 1957s together into one group, all the 2007s, all of the 1962s, the 1967s, etc. So here we are grouping all of the things that are the same. Now, a quick note on group by. Group by works really awesome for things like year or things like continent or country, where they're all spelled exactly the same in your data set. However, if country is spelled two different ways, like Tanganyika or Tanzania, which refer to the same country, then you're going to have to deal with that earlier on in your data cleaning process. And that takes outside real-world knowledge that you then apply to your data set. All right, so enough for the sidetrack. We have grouped by our year. Now we're going to summarize based on mean life expectancy. And we're going to set that equal to mean life expectancy. All right. And then we will go ahead and run this. And it looks like we have a table with the mean life expectancy for every year in our data set. Excellent. This is way more meaningful, and we could go out and graph this and get some insights from that. But what if you want to summarize by two things, right? So maybe you want to summarize by both year and total population. All right, let's do the same thing, but just add in total population. So I'm going to go gapminder, and I'm going to pipe over to group by, and it's going to be year, and I will pipe again, and I want to summarize by both mean life expectancy, I'll set that equal to mean life EXP, and then in between these parentheses make a comma, and I also want to summarize by total pop. Now we're going to run this and we're going to get an error, and I'll show you what that error means and why it means it. All right, so our total pop will be the sum of pop. Okay, go ahead and run this, and there were 12 warnings. Use warnings NA to see them. So I'm going to go and type warnings. I'm going to run that and see what my warnings are. All right, it looks like we have an integer overflow warning, and R has very helpfully told us how to resolve our integer overflow warning. It tells us to use sum as numeric. All right, let's go back in and fix our code. So we'll go sum as dot numeric, and we'll pass that the pop function. Okay, so we will go ahead and run this now. And you probably also got this error. What happened was I forgot a closing parentheses here. So I'll go ahead and highlight this whole thing and run it again. And you should come up with a table that has the year, the mean life expectancy, and the total population. All right, so the next thing we're going to do is group by two variables. So let's say that I wanted to group by the continent and the year. So I'll take my gapminder dataset. I will pipe it over to the group by function. And then I'll group by both continent and year. And then I will pipe that over to summarize by the mean life expectancy, which is my new variable here. And that'll be equal to the mean of life expectancy and total population equal to sum. I've learned to use as numeric and then population. And we will go ahead and run that whole sentence. Run it there. And you get the mean life expectancy and the total population for every continent and every year. All right, so now you go ahead and try. So I'd like you to try to write two scripts. First, filter the data to find the median life expectancy and median GDP of the United States. So we only want it for the United States, and we're looking for median life expectancy and median GDP. Okay. The second task is to group the data to find the median life expectancy for every country. Okay, so go ahead and take a few minutes to write those two out. That is what you're going to submit today. And when you finish it, go ahead and come back and we'll do a very simple visualization just to put all of the work that we've done into action. So go ahead and pause the video and work on those two problems right now. All right, welcome back. Now we're going to do a simple visualization. The first thing that we want to do is some transformations on our data set and save it to a new data set that we can call. I want to group by the years so that I can look at a time series. And I'm interested in total population and mean life expectancy. So I'm going to make my new data set, and I'm going to call it by year. I'm going to assign it to the Gapminder data set that has been transformed to be grouped by the years and has been summarized by total population, which we will calculate here. And that'll be equal to the sum of the as dot numeric of the pop. And then we'll calculate mean life expectancy, and that will be equal to the mean of the life expectancy column. Okay. All right. So we will go ahead and run that, and as expected, nothing comes up. So we want to inspect the head of our brand new data set here. So we will call head of by year, and this looks like exactly what I was anticipating. We have three columns here. We have the year, and then the total population, and the mean life expectancy. And we're not concerned here with GDP or with the country names or anything like that. We just want to know on a global level, what was the population and what was the average or mean life expectancy. All right, So we are going to use ggplot, and ggplot comes in with the tidyverse, so you don't have to load any new packages or anything. And we're going to plot just the year and the total population, nothing fancy. All right. And we're going to say ggplot, and we're going to pass it the by year dataset. And then we're going to say our aesthetic is the simplest aesthetic ever. X equals the year, and Y equals the total population, that variable we just made. We'll close both of those parentheses, hit a plus sign, and then we need to tell it what kind of thing to draw. We want to draw a point, so geom point, and then open close parentheses. Go ahead and run that, and you should get a graph here that is a very direct correlation. There's a very strong positive correlation between the total population and the year. This should be not surprising at all, because in the past 60 years we haven't seen any major pandemics or anything like that. So this is exactly what we would have expected. All right, so now let's go ahead and expand our limits down to 0. You'll notice that our total population starts here at about 2.4 billion people, but that's not always representative. Most statistical software programs will start your graph at whatever the lowest number is for your data, but often we want to start our graphs at 0, because there is the theoretical possibility that there could be 0 people on the planet. All right, so we'll call our ggplot library, we'll pass the same data set, the by year, do the same aesthetics, x equals to the year, our y equals our total population. We want to have the same geometry, so plus geom point. But we also want to expand our limits. So I'm going to put another plus sign and then hit enter so it's all within, so I can see it all on the screen. And we'll type expand limits. And then you have to tell it either your x equals 0 or your y equals 0. In our case, we want our y-axis to start at 0. It wouldn't make sense to start our x-axis at 0, because then we'd be starting at the year 0 AD, and that doesn't really make sense. So we set our y-axis equal to 0. I have made a typo. Hopefully you wrote expand, not just expand. And we have expanded our limits here, right? And now we can see that our y-axis starts at 0 rather than 2.4 billion. Okay. All right, but this isn't that interesting. You know, it's just a bunch of black dots. Let's add one more variable, and that will be all. We're going to make a new data set that is by year continent. And our new data set is going to be from the Gapminder, and we're going to pipe the Gapminder over to group by the year and the continent. So we'll group by both year and continent. And then we still need to summarize. So I'm going to pipe that over, and then I'm going to summarize by both the total population and the mean life expectancy. So total population, sum as numeric, and pass that the pop, and then the mean life expectancy, just as we've been doing, the mean of life expectancy. All right, and then we'll go ahead and run that, and we don't see anything, which is exactly what we would expect. So we'll inspect it and make sure that the by year continent looks how we would have expected. And that's exactly what we were hoping for. The year 1952, we have each continent. 1957, we start again with Africa, right? We have the total population and the mean life expectancy for each. So now let's go ahead and plot this. This is going to be a little bit more interesting because we are going to use color for our continent. Okay? So we'll call ggplot, and then we'll say by year continent, and our aesthetic will be x is equal to year, y is equal to total pop, and color will be equal to continent. And this continent. And this will make our dots different colors based on the continent. And we'll talk next week about categorical and numeric variables and different ways to display them. We'll close that out, and then we'll add to it. We'll say that we want you to be a point, and we want to start by expand our limits, expand limits, and y equals 0. Go ahead and run that. So if you run that, you should then get each continent displayed in a different color and the total population by year by continent. All right, so now it's your turn to try. I'd like you to try to visualize the mean life expectancy of each continent as a function of time. What this means is that you'll have 3 variables. You'll have year, mean life expectancy, and continent. And using the by year continent dataset, you should be able to make a very similar visualization to this of the mean life expectancy by the year for each continent. So go ahead and run that. Go ahead and build that. And ultimately, you'll submit 3 things. You'll submit the 2 scripts that you wrote here, where you filtered the data to find the mean life expectancy and GDP, and you grouped the data to find the median life expectancy for every country, and you will submit your visualization, your PNG or PDF or whatever, of the mean life expectancy of each continent as a function of time. All right. I hope you enjoyed this tutorial. If you have any questions, feel free to ask, and I will see you next week. All right.